Already you have learnt how the value of g it varies with respect to the altitude and depth. Now we are going to learn about how the value of acceleration due to gravity it varies with respect to the latitude. You know the meaning of latitude. In the case of Earth, there are several horizontal and vertical imaginary lines are drawn. The horizontal lines around the Earth which are drawn at various levels, they are all called as what is this? Latitudes. Here one line is drawn. This is also one of the latitude. With respect to the line which is drawn around the Earth in the middle, exactly at the equator, there the latitude angle is 0. Are you clear? So this is the equatorial line. Equatorial line is one of the latitude lines. There the lambda value, angle value is 0. But the latitude angle at the pole is 90 degree. The latitude angle that is mentioned by the letter lambda. Again I will repeat. The latitude angle at the equatorial line is lambda is equal to 0. The same latitude angle lambda value at the pole is 90 degree. Here due to the spinning, what will happen? The value of g will change. Are you clear? So at various latitude levels, the value of g value it changes. That's why the title is given as variation of g with latitude. Here the value of g is different. Here the value of g is different. Are you clear? At various positions, the value of acceleration due to gravity, it changes. Now we are going to derive the formula to calculate the acceleration due to gravity at various latitudes on the surface of the Earth. Before going to derive the value of g at various values of latitude, certain assumptions must be clearly understood. Are you clear? So let's see the assumptions one by one. Already in the previous chapters, we have learnt about there are two kind of frame of references are there. One is called inertial frame of reference and another one is called non-inertial frame of reference. Inertial frame of reference in which the Newton laws are obeyed. Are you clear? But in the case of non-inertial frame of reference, the Newton laws are not obeyed. Are you clear? In general, all rotating frames are non-inertial frames, that you should know. Now we have to see whether the Earth is inertial frame or non-inertial frame. In certain cases, Earth is assumed as inertial frame. Are you clear? In third chapter while learning the laws of motion, clear already we have learned that Earth is considered as inertial frame of reference. That's why I have written the sentence here. Though it is considered as an inertial frame of reference, since it is spinning about its axis, the Earth it becomes a rotating frame of reference. All rotating frame of reference must be taken as the non-inertial frame of reference. Are you clear? And one more thing is, since the Earth is spinning about its own axis, since it is a rotating frame of reference, all object will experience the centrifugal force, that is a pseudo force. Are you clear? Since the pseudo force is acting, since the Newton laws are not valid, the rotating frame, Earth must be assumed as a non-inertial frame. So whenever any object, when it is kept on the surface of the Earth, because of the spin, what happens? That object will experience the centrifugal force. What is centrifugal force? Because of the centripetal force. Centripetal means the force which is acting towards the center. Are you clear? That object that is pulled towards the center, no? Are you clear? Whenever any object moves in the circular path, that object will be pulled towards the center of the circular path. So centripetal force is acting. Definitely, is it clear? There must be another force, reactional force, that is called centrifugal force, that is acting away from the center. Are you clear? So centripetal force and centrifugal force both are acting in the opposite direction. So centrifugal force is acting clear away from the center, that is acting in this direction because of the spin. So we have to mainly talk about centrifugal force in this discussion. Here already I have written one more important point. Look at the sentence which is written here. If earth were not spinning means it is an imaginary one. That's why we have written the term were not spinning. If earth were not spinning, that is imaginary. If earth were not spinning, if such assumption is taken, only one force will be acting. Gravitational force alone will act. That gravitational force is nothing but mg. That alone will act in this direction. But actually what happens? Earth is spinning about its own axis. So whenever the earth is, its spin is considered, what will happen? Definitely there will be a centrifugal force. Are you clear? The centrifugal force that is acting in this direction. Are you clear? That centrifugal force that is acting in the opposite direction of mg. Are you clear? So additional centrifugal force is acting. You have to understand the concept. Are you clear? So whenever the earth spins, which one is acting? The centrifugal force that is acting in this direction, its horizontal component must be taken. I am going to draw all the diagram later, just I am explaining now. Here in this direction, centrifugal force will act. So centrifugal force also must be considered, its horizontal component. The horizontal component of the centrifugal force, that one will act here. That's why I have written, apart from the mg, additional centrifugal force also acts on the body. So in this derivation, while calculating g with respect to the latitude, we have to consider the centrifugal force. Understood? Now I am going to teach you how to calculate the centrifugal force which is acting on the object whenever the earth spin about its axis. You have to imagine that one object is placed on the surface of the earth. With respect to the equatorial line, I have calculated the angle, latitude angle lambda in between the equatorial line with respect to the position of the object. Clear? Here I have drawn the radius of the earth, or in between the object and the center, that distance is taken as radius of the earth. In between this location and this equatorial line, there you are able to get the latitude angle lambda. Are you clear? Now, with respect to the object, since it is spinning, earth is spinning with respect to the axis like this, here when earth spins, the object also spins and it is traveling in a circle. Are you able to understand? When earth spin about its axis, that object also moves in the circular path. Now I have drawn one imaginary circular path. So this dotted circular path, that one represents the movement of the object in the circular path when earth spins. Here the imaginary circular path is there now. Its radius can be taken as r dash. You have to understand one thing, that r, capital R is the radius of the earth, r dash is the radius of the circular path, clear, which is drawn here. Are you clear? This is the path in which that object moves. For that separate radius is there, r dash. Know the difference between r dash and r. Now I would like to calculate the value of which one? R dash. How to calculate the r dash value with the help of r? The same thing is drawn here. Here lambda is there. The same alternate angle. This angle and this angle both are equal. Therefore, since alternate angle, opposite angles are equal, the same lambda is drawn here. And this is nothing but r. Now this r, it can be taken as a vector and it can be resolved into two components. What are they? So here r sin lambda. So in that format we can write. Can you understand? So here how this one could be written? This one could be taken as r cos alpha. Are you clear? So r is resolved into two components. What are they? R sin alpha, sin lambda, and this is the horizontal component. Therefore we can take it as r cos lambda. So r is resolved into two components. Since r is acting here, r is measured here, R dash can be taken as R cos lambda. Again we will repeat. To get R dash, what we have to do? R is resolved into two components, R sin lambda, R cos lambda. R cos lambda will act in this direction. Therefore, this distance R dash becomes R cos lambda. So, now we have got the formula for R dash. Wherever R comes, there you have to substitute R cos lambda. So, what's our aim? We are going to calculate the expression for centrifugal force. Are you clear? Where the centrifugal force is acting? That is the question now. Here, the most important thing is, this is the direction in which the centrifugal force is acting. So, whenever the earth spins, a force is acting, pseudo force is acting in this direction. So, the force which is acting away from the center, this is the center point of the circle, no? So, this is the direction in which centrifugal force is acting. Are you clear? That one can be called as, what is this? FC. Are you clear? Centrifugal force, or we can call it as centrifugal force. So, this is a direction in which centrifugal force is acting. Are you clear? In general, to calculate the centrifugal force, which expression can be taken? Centrifugal force is numerically equal to centripetal force. So, what is the expression for centripetal force? Centripetal force expression is mv square divided by r. That is the basic formula. So, it's the same mv square divided by r expression that can be taken to calculate centrifugal force also. So, what is the basic formula? mv square divided by r is the formula. Are you clear? mv square divided by r is a formula to calculate the centripetal force. Here, centripetal force is also acting. This is the direction of centrifugal force. For both, same formula to be used. Here, this is the circle in which that object moves. Therefore, r dash must be written. So, this much amount of centrifugal force is acting in this direction. We know the expression for r dash. Now only we have calculated mv square divided by, instead of r dash, we can write, clear that formula. Before that, we can write in this expression that v, clear, already we know in lower class is clear. Already we have learnt about which one? V is equal to r omega. This is a relationship between linear velocity and angular velocity. Here v dash is equal, v is equal to r dash omega can be written. V is equal to r dash omega can be written. So, instead of v, substitute this one. Are you clear? Instead of v, this one can be substituted. M. Instead of v, substitute r dash square omega square divided by r dash can be written. One r dash can be cancelled. So, what is the remaining thing? M r dash omega square can be written. Are you clear? So, this is the expression to calculate which one? Centrifugal force. That centrifugal force can be represented by FCF, centrifugal force. Already we know the expression for r dash, already it is calculated. M instead of r dash, we can write r cos alpha, r cos lambda. Instead of r dash, we have written r cos lambda. Omega square can be written. M r cos lambda omega square can be written. So, this is the expression to calculate the centrifugal force which is acting in this direction. Understood? So, up to this I have written. Next we are going to calculate the component. Which one? From the centrifugal force we have to calculate the which one? Centripetal acceleration. Are you clear? After calculating the centripetal acceleration, we have to find out the component of the centripetal acceleration. Are you clear? Already we have derived the expression for centrifugal force. To calculate the centrifugal force, this expression was already derived, m omega square r dash. From centrifugal force, we are going to calculate the centrifugal acceleration. From Newton's second law, we are able to easily derive the new centrifugal acceleration expression. What is the formula? F is equal to ma. That could be developed and you can rewrite it as what is this? Centrifugal force is equal to the product of mass and centrifugal acceleration. Centrifugal force is equal to mass into centrifugal acceleration. So to get the centrifugal acceleration, what we have to do? The expression of force, that expression of force must be divided by mass. Now I am going to get the expression for centrifugal acceleration. How to write this? Force expression is here. M omega square r dash whole divided by, that should be divided by mass. Now cancel both. You will get the expression for which one? Omega square r dash. So this is the expression for centrifugal acceleration. Where the centrifugal acceleration acts, that is very important. Along the direction of centrifugal force, that centrifugal acceleration also acts. That is very important. Are you clear? If there is a force, there must be some acceleration that is acting on the object. So this is a direction of centrifugal force as well as centrifugal acceleration. Make a note. In the next step, I am going to take the component. So clear, the component of the centrifugal acceleration is going to be taken. Which component to be taken? That is very important. Now here, draw the line in this direction. The same line to be extended. So this is the direction in which the component of the centrifugal acceleration is acting. Very, very important one. I am going to get the expression for this one in the next step. Now we are in the final step. Look at here. This is a direction through which the centrifugal acceleration is acting. Its expression is omega square r dash. That one was already derived. Here this is the direction through which the horizontal component of the centrifugal acceleration is acting. How to get the expression for the horizontal component of centrifugal acceleration? Here lambda is there, latitude angle. Same latitude angle lambda, that one will be existing here. So this omega square r dash, this acceleration, that can be resolved into two components. So this is a horizontal component, definitely there must be a vertical component. Here this one does not contribute anything, vertical component. Therefore the horizontal component alone to be taken into the consideration. Therefore to get the horizontal component, what we have to do? This omega square r dash must be multiplied with cos alpha. Already you have learnt about in vector analysis itself. Are you clear? If any vector, if it is multiplied with the cos of the triangle, you will get the horizontal component. Omega square r dash cos lambda, that one gives you the horizontal component of the centrifugal acceleration. Now the most important thing is, this is the direction in which the component of the centrifugal acceleration is acting. This is the direction through which the acceleration due to gravity is acting towards the center. So two accelerations are there. One is component of omega square r dash, that is acting in this direction. This is the direction of the g. Both are acting in the opposite direction. Now we have to find out the net value of g. Are you clear? G dash, that can be called as g dash. What is g dash? G dash is called as the acceleration due to gravity due to latitude. Are you clear? The acceleration due to gravity due to latitude can be calculated. That is our aim. Are you clear? That is the net value of acceleration and that is acting on the which one? That object. G dash can be calculated by g, that is acting towards in this direction. Opposite to that, which one is acting? Component of centrifugal acceleration is acting now g minus. Since it is acting in the opposite direction, it can be written as omega square r dash cos lambda can be written. The next step, g dash is equal to g minus omega square. Instead of r dash, already we have derived the expression for r dash. R dash can be removed by r cos lambda. and then one more cos lambda is there outside. Therefore, g dash is equal to g minus omega square or cos square lambda can be written. So this is the expression from which we are able to calculate the acceleration due to gravity at different places on the surface of the earth. If you move from one place to another place, the latitude angle, that one will differ. Are you clear? So depends on the location, the latitude angle will differ. Depends on the value of lambda, the acceleration due to gravity value also will differ. Are you clear? Now let us take two cases. Let us assume that the object is kept here and the object is kept exactly at the equatorial line. So what you have to write? At the equator, at the equatorial line. What is the value of lambda? It is brought from here to there, no, therefore lambda becomes 0. Therefore g dash is equal to g minus omega square r cos square, instead of lambda substitute 0. Therefore g dash is equal to g minus omega square r, cos 0 value becomes 1. Are you clear? So this is the expression. This is to be used whenever the object is placed here. Are you clear? So this is the expression from which we are able to calculate how much amount of acceleration due to gravity is acting when it is kept exactly at equatorial line. Are you clear? The next one is when the same object, when it is brought here at pole. So you are moving, you are making the journey from here to there. So what would be the angle? Lambda will be equal to 90 degree. So what would be the next expression at poles? At poles, so clear, g dash is equal to g minus omega square r cos square. Lambda must be written. Later you have to substitute, is it clear? When you are moving from here to there, no, therefore lambda value must be equal to 90 degree. So g minus omega square r cos square 90 must be written. Are you clear? Cos 90 value is equal to how much? Cos 90 value is 0. Therefore g dash is equal to g minus, this entire factor becomes 0. So therefore g dash, that one will become g. Are you clear? So g dash, that one becomes g, but here the g value to be subtracted from this factor. So definitely this value would be minimum. Are you clear? This value would be minimum. Are you clear? Very important one. So the final conclusion is, are you clear? At the equator, the acceleration due to gravity is minimum. Here g dash, that one becomes equal to g. Therefore at poles, the g value will be maximum. You have to understand the concept very thoroughly. So when earth spins, it's clear, this variation occurs. Acceleration due to gravity at the equator, the value becomes minimum. At poles, the g dash value, that one will attain the maximum value. So this is the conclusion. Clear, problems are there. By solving the problem, you can understand the concept very thoroughly. Okay, thank you.